Okay. Hello friends, good evening.
Good evening.
Alright. All of you are there? Alert and fine?
Yes, sir.
Yeah. Now,
Yes.
aram se keep your mind open and learn science aram se. See students, see, I have introduced significant figures, rule 1, rule 2, rule 3 and all this. Okay, fine. Because I have to tell it in Sankshipt, everything I have put in. But now all of you just give a thought to this. What is all these significant figures, rules, errors and things like that? What is all this? All this is about, physics. Physics means it's something, it's a science which will take you closer to the truth. There is nothing like absolute truth in this world. Please understand. Okay? Everything is relative. So here we are trying to speak maximum truth. Okay? And in a very precise and concise manner without giving room for much ambiguity. That is the whole idea. So here you see, when you do any measurement, see, if I tell you to measure the length of this book, okay, so, well, you take a simple scale, you will say the length of this book is, say, some 20.2 centimeters. Now, somebody will bring a much better accurate scale and say 20.23. Somebody will say 20.234. Somebody will say 20.23456. Like that it goes on. So, who is right? Well, everybody is right. It all depends upon, what instrument you have got, how accurate is that instrument, and with that, you are telling the maximum truth. Got it, friends?
Yes, sir.
So, that's it. So, therefore, now, and our physics subject is so beautiful, no? It tries to convey maximum truth in a minimum manner. So, what I said yesterday, supposing the length of a pencil is 1.5 centimeters. Okay, 1.5 centimeters. So, this has got whole lot of meaning. You see that. First and foremost thing, we are following a convention. What is that convention? This digit, okay, or whatever digit is going to come here, these are all going to be what? Definite. And we can add one more digit based on our guess. Okay, so this is certain and this is uncertain. Now together it forms the total number of significant digits. Correct?
Yes, sir.
So when I write 1.5 centimeters, it is clear that I have taken a scale whose markings are like this: 0, 1 centimeter, 2 centimeter, okay, so on and so forth in centimeters. So without saying anything, 1.5 centimeter means I have taken this scale and I have recorded the value. Clear?
Yes, sir.
So that is how you have to see. And now the second thing is, addition. We are now adding two numbers and trying to establish the significant digits of this. Say now I will take one scale and measure the length of one pencil, which is 1.5 centimeters. This is pencil number 1. Then I will take pencil number 2. Okay. Say another student has got a better scale, which is in millimeters. So he will do the measurement of another pencil and give it as 2.56 centimeters. You understand, student? Hello? So definitely here he is using a centimeter scale and here he is using a millimeter scale. Correct?
Yes, sir.
Now I will keep these two pencils together like this. One is measured like this by student number 1, another is measured by student number 2. Right? And now I am going to ask you, what is the total length of this? Right? So what is the total length of this? Of course, you will add this two. Okay. So you will say 6 here, 5 plus 5, 0 here, 3 plus 1, 4 here. Hello, are you with me?
Yes, sir.
Now you see, what should I do here? See the length of the pencil, 4.06. Should I write it like this? Or is something is wrong here? Definitely you see, wait a minute. Definitely you see, common sense will tell us that if this second pencil was measured with this scale, if the second pencil was measured with this scale. Hello, are you with me? Probably you would have recorded it as what? 2.6 centimeters.
6. Yes.
You would have probably recorded, or you would have recorded 2.5 also. Chalta hai. But definitely you would not have recorded the third digit. Correct?
Yes, sir.
So the essence here is that when I am doing a measurement, now you see student 1 and student 2, and together they form a system. So in this system, if I have to tell the truth as close as possible to the reality, to the truth to the maximum extent, then I have to be careful about this, because this one is not available here. Okay, this digit is not available here. That means I cannot tell very faithfully and confidently about this digit, because my scale, one of the scales, was only restricted to 2 significant digits. And therefore, that prompts me to give an answer which is closer to the truth, and therefore, I will have to report this as 2 significant digits. Therefore, that rule has been made. And how to come to that? Well, we have a system of rounding off. We round it off and bring it to 4.1 centimeters. Is that clear?
Yes, sir.
So that is the way, that is why, when you add, you are going to take the number of the least number of decimal places. But bear it in mind, when you are adding, this and this should be in same units. See, 2.01 centimeters and you got here 4.55 meters. You cannot simply add them together. You either convert this to centimeters or convert this to meters, and then go about doing the addition. Correct? So in that case, what happens if you convert this into meters? This will become what? 0.0201 meters. Hello, are you with me?
Yes, sir.
Now you see, now you can add these two, right? Now again, when you add these two, you see here, see, now here, here you see, you find 4 digits after the decimal point, and you find 2 digits after the decimal point, both the units are same. And therefore, your addition now must contain only 2 digits after the decimal place. And therefore, this addition, if you simply add, is going to give you 7 and 5 and now therefore now you have to report the number of digits after the decimal point to be 2, and therefore you are going to simply report it as 4.57 meters. Got it, friends?
Sir.
So therefore, what I am trying to teach you students is, you also have to apply your mind a bit to understand, the reasons why those rules are made, because you see, your examination questions are coined in such a manner that if you have put an effort to understand the significance of the significant digits, the system of measurements, and why, then you will be able to comfortably answer the questions in the examination. Okay, that's what is the essence of it. And physics is all about trying to come very closer to telling the truth. Okay, that's it. And see, there are 2 ways to approach the truth. One is through God. Other one is through science. Okay, we are following the path of science. Okay, fine.
So one doubt, sir.
Yes, please.
Sure. That 4.1, sir. One means uncertain or certain, sir.
4.1, where? Here. 4.1. Definitely. See, 4.1 one is uncertain.
Uncertain.
See, now that's a good question you asked. See, gentlemen. See, when you do the measurement only, the question of certain, uncertain will come. But after manipulation, that question will not come. I mean, here only the question of certain, uncertain. But now what you have done here, you have added these two and you have got this. No. Hello?
So both are certain, sir.
No, you should not talk about certain, uncertain. See, after manipulation, you have got a number, okay, and you have followed certain rules, and rules are formed because of, it has to convey maximum truth, and you have got this answer. Now, don't try to say whether it is certain or uncertain and all those things at this stage. This stage, yes, you have to comment, right? Okay? That's it. See, once you manipulate it, no, then it is just you are manipulating to get the final answer. Okay, as per the rules. That's it. Now, no, you have to say it is certain when you are measuring and reporting. Only at that stage. After that, you should not use those terms. Done. Okay. We have gone through this. See, it is very clear here. Here there are only 3 significant. Here there are 5, because it is a measurement.
Yes, sir.
Okay. Right. We have done this. We have gone through this. Right. We have gone through this. We have gone through this. Okay, we have gone through this. We've gone through this. This problem was quite important and interesting. So once again, I am showing you here. Okay, now if you see the things here, this is in meters. How many significant digits are there? 4. 4. How many are there? 3. But you see, the units are different. Okay, keep that in mind. So now here you see you are multiplying this. You are multiplying these 2 numbers, length and breadth. So you simply multiply, you get this number. Multiply breadth and the thickness. And when you are multiplying this, you have converted centimeters to meters. Mind it. Okay? And then you have multiplied. And then again you have multiplied. Right? Steps in this. Now you see, in this multiplication, that is you are multiplying these 2, right? You have to retain the least number of significant digits, that is 4. And therefore, you retain 4. And when you multiply this with this, you have to retain 3 significant digits, you have retained. And when you multiply this with this, you have to retain 3 significant digits, you have retained. Got it?
Yes, sir.
See, follow this rule. It's a very good example. See, I am telling you this example from my student days, this is used. This particular problem. You will be surprised. Right? Then the next step is, multiply by 2. 2 is just a number. And therefore, 2 into this one will give you this. Again, you see, here, it is simply multiplication. That means what? You are adding this twice. You are adding this twice. Again, each number will contain 4 significant digits, and therefore, the final answer should also contain 4 significant digits. Everywhere, the rule is being applied. It is not just, whimsically writing something. I hope you are appreciating the rules at every stage.
Yes.
Now, coming to this. Now, finally, you have to report the area. You have to report the area. Now, when you are reporting the area, area here is a sum of 3 terms. I suppose you understand this. That is this term, and this term. Got it? There are 3 terms there. Hello? Now, when you are reporting this area, when you have multiplied, so when you are reporting the area here, you have multiplied this number with this number, this number with this number. So that means now here itself, you see, you are multiplying this with this, and it has got 3 significant digits. Okay, so here you see, you will end up with 3 significant digits. If you multiply this with this, you have ended up with 4, but here you have ended up with 3, here you have ended up with 3, and therefore when you come to the final answer also, you should now scramble around and see which is the least number of significant digits, and again here you will find 3. Therefore the final answer should also be 3 significant digits, therefore you round it up to 8.72 meters. Did you get it, friends?
That the 3 significant figures is not a big rule for area.
3 significant digits is not a?
So it's like that is dependent on the question.
It is dependent on the question. It is dependent on, since the area can contain maximum 3, why it should contain maximum 3 significant figures? Why the area should contain 3 significant figures? Because one of the terms is this into this, or this into this, and there are only 3 significant figures.
That's only for this case, no, sir?
How? In this case. Hello, in this case, got it?
Okay.
This is the rule. See, this is the basic rule. Keep this in mind. Okay. See, if time permits, we'll take up some more issues and discuss this. Likewise, when you do the volume, okay, when you are doing the volume also, the same rule will hold good. And therefore you have to end up with 3 significant digits. Correct?
Yes.
Very important, this problem. Simply don't say, okay, like that. Apply yourself and please learn. So now we will go into the next section, errors in measurements. Now don't read anything there. Right, also you will read. Better we blank it out. Okay, now listen here very carefully. In spite of the best efforts, the best instruments used, whenever you make a measurement, it cannot be said that there is a perfect measurement. There is nothing like perfect measurement. Okay, hello?
Yes, sir.
Yes, sir.
There is nothing like perfect measurement. Now, then what should we do? So that means now I do a measurement and I report. Say I have done a measurement and I have reported. But now, if I am not sure, then I may report I may not report the absolute truth. So there can be some falsehood in that. For example, you go and buy rice in physical balance, right? Say you will ask him for 1 kilo rice. So he puts a 1 kilo stone and he goes on pouring till the balance becomes balance. It's level. Then he says it is 1 kilo. Are you sure it is pakka 1.0000 kilos? Hello? Come on, all of you keep your mic open and say hi. Are you sure it is 1.0000?
No, sir.
No.
Definitely not. Okay, yes, but there is a possibility that it can be. But that possibility is very, very less. But then, what are you going to do? Okay, if the quantity is more than 1 kilo, the shopkeeper loses. If the quantity is less than 1 kilo, the customer loses. Okay, so therefore now somebody has to be cheated, correct? Either the shopkeeper or the customer have to be cheated in a way. But now, that means now the world is full of cheating, correct? But it is not the case. Here, what is done here is, look Baba, I am using this scale. This is 1% accurate. I will say it is 1% accurate. What do you mean? That means now, whenever I measure 1000 grams or 1 kilogram, okay, then and I am saying I am using a balance which is 1% accurate. That means whatever measurement I do, it is between 900 grams to 1100 grams. Agreed? So please understand this. 1% means
How do you define that?
Sorry. 1% means 90 grams. I'm sorry. 1% means 90 grams. I'm sorry. Thank you. See, one student is very alert. I'm very thankful here. God bless you, man. So this is 1010 grams. Thank you. So that is it. If I say it is 1%. So if you see the balance, right? If you see the balance there, okay. Next time when you go to the shop, you see it is marked here 1% or 10% or 2%, whatever. It is marked by Bureau of Standards. Now with this marking, if the rice that you get is between these quantities, if you are getting the rice between these two quantities, then there is truth in that. Understand? But if you are getting lesser than this or more than this, that is not right. Then there is something wrong here. Then that is cheating. But if it is between these two values, it is not cheating, it is the truth. Got it?
Yes, sir.
So here you are telling him, look, my scale is this much accurate. That means there is a possibility of this error. Now only I am telling you. Namge ashtu error idre bekagilri. Namma pakka 1 kg means I should have 1000 grams, then only I will buy. Sorry sir, in my balance I cannot do that measurement. You go to some other shop. Simple. So this is how you see we speak truth in physics. We tell you that, well, there is an error. You have to accept it, then move on. If you don't want to accept it, fine, again you move on. So there is no clash. Is that clear, students?
One dot, sir.
Yes, please.
Sir, that will be 1% error, no, sir. Accuracy will be 99%.
No, 1%. I call accuracy is accuracy. See, accuracy of the scale is 1%. If I say like that, if I see on the scale, if it is reported like that, okay. See, that's the convention used. That's the convention used. Convention used. Okay, convention used. Right? And with that convention, well, we are going it like this. Yes, there is something here, that some conventions are followed. So okay, so we have to have the knowledge of the conventions that are used. Okay, that is it. Now that means now here there is a way of reporting the error. There is a way of reporting the error. So now you see, when I talk about error can be many ways. Error can be many ways. For example, you see, in this balance only, supposing there is some friction here. So what happens due to friction? This balance without any material on this can be like this. If there is some friction, okay, or even though the balance is like this, okay, there is good lot of friction here. So even though you have loaded this with 100 grams, okay, you have loaded this with 100 grams, of course you have kept 100 grams stored here. If there is tremendous friction here, then this balance will still be steady only. So you will end up adding more here till the balance slightly tilts. Got it? So there can be error due to something like a friction here. Okay, so many factors can contribute to this. Okay, etc. So now we will try and understand some of the aspects of the error at +2 level. Okay, that's what we are going to learn here. What are the different types of errors and how we have to deal with those errors. Okay, for example, see here, I have a scale. It is graduated 1, say 2, then 3. Okay, I have a scale. Okay, now you assume that this is the pointer. This pointer is here. Where is it located? Is it showing 2? Say, wait, I'll do one thing. I'll say this is 2, this is 3, this is 4, and this is 5. I am showing this pointer here. Assume that this is a pointer. So this pointer is showing what? Is it showing 2, 3, 4, what?
3, sir.
Is it showing 3? Is it showing 3 or 2 or what? 3, sure. Pakka 3, not 3.1.
I'm not able to see that. Yeah.
You're not able to see it. Okay. Now can you see?
Yes.
How much is it? Something like 3. Okay, 3. Something like that. Now what I want to tell you is, see, if I am seeing it like this, I am seeing 3. But if I move like this, I am seeing it at 3.2. I have not changed the position. If I move like this, it is 2.8. Got it? इसको क्या बोलते हैं हम? कैसा एरर बोलते हैं हम? What error? What error? Human error. Okay, I heard it as human error. Okay, then. No, it is called parallax error. See, most of the errors are human errors only, right? fewer instrumental. It's called parallax error. Understood? So therefore, if you see such case, there is a mirror behind it. There is a mirror. If you see very carefully. Hello, are you with me?
Yes, sir.
See, I have got a meter here. There is a small mirror here.
Yes.
The small mirror. Why that mirror is there? See, now when I see this pointer, the image of the pointer is also on the mirror. Now when I see it, the object, that is this pointer, and its image should coincide. Then I am seeing without parallax error. Then I should see what is the radius. Got it? So some ways we are avoiding it, but sometimes it's unavoidable. Okay, that's it. So we are going to study many of such errors one by one, and well, we'll enjoy the subject. I'm sure you've gone to the laboratory and you have performed many experiments with verniers, spirometers, and things like that. You have done so, right?
Yes.
Yes. So we're going to talk or discuss all those things. Please learn this, don't simply study these things. Errors in measurements. The difference between the true value and the measured value of a quantity is called error in the measurement. Simple. Errors may arise from different sources and are usually classified as follows. Systematic or controllable errors. Systematic or controllable errors. Now you see, this wording has got a lot of meaning. Systematic errors are errors whose causes are known. They can either be positive or negative. Due to the known causes, these errors can be minimized if not eliminated. Systematic errors can be further classified into three categories. Now, watch out, my dear friends. Each word here can get converted into wonderful questions. And if you see the questions in this particular chapter, you will be surprised. Units, dimension, measurements, and you get some 300, 400 questions just based on these words. It's not about by-hearting those things or saying, oh, this we have to be this. But you see, if you understand each of these words, understand, not study and know, then you will not feel tensed with the magnitude or the number of questions that are asked, etc. See, here what I am saying is, the systematic and controllable errors can be eliminated, true or false. There's a question asked. So here you see, it cannot be eliminated, it can only be minimized. So if you have understood this meaning, then you would have written the answer. Okay, otherwise no. And they are both positive and negative. And they are controllable errors. That means, see, for example, I told you friction in that physical balance. That's a systematic error. You can minimize it by putting a lubricating oil, correct? Hello?
Yes, sir.
Right. I want to hear you, students, please. Instrument. So this can be divided into three instrumental errors. These errors are due to imperfect or erroneous manufacture or misuse of the measuring instruments. They can be reduced by more accurate instruments. Simple. Instrument errors come under systematic, controllable errors, imperfect design, or erroneous manufacture and misuse of the measurement. Anyways, those things you can understand carefully. Environmental errors. These errors are due to changes in the external environment conditions such as temperature, pressure, humidity, dust, vibrations of magnetic and electrostatic fields. Now, have you ever come across this type of an error when you have, in your lifetime, and where this is minimized? Well, I'm sure you would have gone to a shop and you would have bought
Yes,
some.
sir, it happens.
Tell. Where have you seen?
Sir, my father had a small device. Yes, sir. It used to check the level of tables and everything. There was an error in that. So, once kept it on flat table only, but still it was not showing flat. So that was he said something. It was because like we were in 90 or something like that. So, like, that's why. So then he drew another circle. He was like, this will now show flat area correctly.
I didn't get you. Anyways, I didn't get what you said. Fine, not an issue. Now you see, I am sure all of you have gone to a goldsmith, right, to buy some golden ornaments and all. And you would have seen a balance being used there. Correct? Hello?
Yes. Yes.
So there you see the balance is very, very delicate. Right? Very, very delicate. Right? And then it is kept in a box with glass. Isn't it? It's kept locked in a glass. But when you go to shops, you don't find any glass casing and all. Why? See here, you are going to measure here in milligrams. Okay, milligrams. So if you have this balance and you are weighing some gold and all, and even you are breathing the air, okay, that can, see, if I am breathing on this fan, then the pressure here is more. This will show more weight. And another thing is, if this is an electronic balance, then this has to be temperature controlled. Otherwise, electronic devices are prone to temperature. So therefore, you see, here as far as the weighment is concerned, there is electronic instrument, so it depends upon the temperature. And yes, these are very sensitive, and our breathing can affect it, so pressure can also have a bearing on this. And of course, humidity. Humidity can play its own role. Dust particles here can settle here or here. Some more dust particles here, then your weighing will be wrong. Okay, and of course, this is kept on a rubber padding here. Okay, because somebody walking or some table banging, this balance can get vibrations and so on and so forth. And then of course, magnetic and electrostatic shields, all are necessary here, because you see, now these are all iron, these are all metal parts. And as you know, if there are magnetic fields here, and if this metal part is in motion, then that can induce currents in this. And these currents in this and currents in this, if they are flowing in the same direction or opposite, they can attract or repel, and the error can be there. And of course, electrostatic. So if there is electric field here, again these things can get charged, and then that can cause force. So many issues can happen. So therefore, you see, certain measurements, the environmental errors can be there. And if you have knowledge that this can happen, then you will take adequate precautions to ensure that it is well shielded. And that comes under the heading called systematic and controllable errors. Okay? Then observational errors. These errors arise due to improper setting of the apparatus or carelessness in taking observation. For example, parallax. Just now I explained to you. Okay? See, improper setting of the apparatus, zero error. See, your vernier, you have used the vernier, so it can have zero error. Okay, here also you see, as when both the pans are empty, the meter is supposed to show 0, 0, 0, but sometimes it doesn't show 0. Then there is a button here called tear. Tear button. So if you press this, then the meter is set to 0. Okay, so 0 error, all those things. So here you see, these are all the observational errors that you see here. Got it, friends? Right. So understand this. Nothing to buy heart here. Nothing to buy heart. So systematic or controllable errors, instrument, because wherever you can control, instrument, environment, observation errors. Okay. Random errors. Random means, it is not under your control. It can happen. You don't know how it happens, but it happens. Okay. And that is what we classify it as random errors. Okay. This is obvious. This term random, it is very common. Let's understand the meaning of this. These errors are due to unknown causes. We are not interested in the cause. Because if we know the cause, then we can think about minimizing it. Right? Just then it comes under the category of systematic errors. Okay? But we don't know the cause, therefore we cannot put it under the heading of systematic cause errors. Therefore, they occur irregularly and are variable in magnitude and sign. Plus ಇರಬಹುದು, minus ಇರಬಹುದು. Since the causes of errors are not known precisely, see, please understand. So, we can say, okay, because of this there is a cause. But we cannot exactly say this is the reason why it is there. See, sometimes you see one person is acting funny. So it's a fact that person is acting funny. Now, if you have time, you can build theories around it. Oh, because this happened to him, that is why he is acting like this. Oh, because that happened to him, he is acting like this. So and so forth. So we don't know the exact precise reasons why he is acting funny. But the fact is that he is acting funny. You got it? So there is precisely what you have to understand here. Since the causes of errors are not known precisely, they cannot be eliminated completely. For example, when the same person repeats the same observation in the same condition, he may get different readings at different times. He will tell the truth, sir, I just took the reading, sir. See, many times it has happened. As an examiner, I have seen. As a student, I have faced the problem. Because, see, especially in electronics engineering, what happens? The student makes the setup and then he takes the measurement. And then he writes down the measurement. And then he tells the examiner, sir, I have got the readings. Then the examiner will be observing, will be seeing something else, some other students' readings and all. Say after some 10 minutes, he will come to this table. So this student is very happy. So he said, sir, I have got the reading. Then the examiner, as an examiner, I went and I said, Array, you have written here 2.34, but it is showing here 3.3. How come? It is not right. No, sir, I just measured, sir, it was 2.3, sir. But now it is showing 3. See, now in front of you, same voltmeter I am using. I am getting 3.3. I am challenging the student. Sir, no, sir, really I got 2.3, sir. I measured it, sir. But see, I am also measuring. Are you understanding my conversation with the student? Hello? This is with regard to an amplifier. This regard with an amplifier. Then I told my student, okay, friend. So when you measured, it is 2.3. Now when I came, it is 3.3. So the reading has changed. Yes, sir, it has changed. If you tell me the reason why it has changed, I will give you full marks. I told the student. You tell me the reason why the reading has changed. The good student said, sir, I will think. Please think. Then I went to the next table, so and so forth. Then after some time, the student called. Sir, I have understood, sir. Sir, this is a transistor, semiconductor transistor. It is prone to temperature changes. So when I took the readings, the current was flowing through it and the heat was getting dissipated in that. And it took some time for sufficient amount of heat to be dissipated there, and as a consequence the temperature increased. And the characteristics of the transistor will depend upon not the heat but the temperature. And since it took some time, finite time for the temperature to change, and during that lag the reading has changed. Okay, are you sure? Yes, sir, I am very sure. Can you prove it? I asked the student. Yes, sir, I can prove it. Prove it and show. Okay, then the student was so confident, he applied his theory and he switched off the instrument. That is, no current is flowing. Then I told, sir, please wait, sir. So I waited. Then after 3-4 minutes, I said I have to go. Then he switched on. Then immediately after switching on, he measured. So it was now showing 2.7. Sir, you see, sir, in front of you, you only measured 3.3. Now I switched off and switched on. It became 2.7 because the instrument, the transistor had cooled. I gave full marks for that. Understood, students? So this is what is learning to do. It's a fact. I have seen many situations like this. So therefore, if you know the science of measurement and the causes of that, you can definitely discourse and it's the quality. It's the quality of the student. He is able to apply the theory. Yes, initially he did not know. When I gave him a hint, he was able to do that. Your examinations are also going to be like this. not only in the mains and NEET, but in the days to come. Right. So therefore, the same reading may appear different times. Random errors can be reduced by repeating the observation a large number of times and by taking arithmetic mean of all the observations. The mean value would be very close to the most accurate. And I'm sure all of us would agree to this. This is what is statistics all about. Okay, so randomness, when there is some quantity random, if you go on doing the measurement n number of times, then the error goes on reducing. Ultimately, it can come very close to 0. Okay, obviously. If the number of observations made is n times, the random error reduces by 1 by n times. So if the random error in the arithmetic mean of 100 observations is x, then the random error in the arithmetic mean of 500 will be x by 5. Got it, students? Hello?
Yes, sir.
Now you observe this statement. You observe this statement very carefully. See, if you take one reading and say the error is so much, okay, and then you say, oh, you reduced by so much, wrong. You see here, it is not simply arbitrarily written 100. Understand? So therefore, whenever you are handling random phenomena, you must start with n number of observations. So you take first 100 observation, okay, and the error is x. Now you increase the observations to 500, now the error reduces to x by 5. That is important. If you say, sir, I did the first measurement, the error was so much, after 10 measurements, the error reduced, wrong. Randomness means you must start with some number of errors, some measurements, and increase the number of measurements. And then compare. Is that clear? See, you have to grasp the sense of mathematics there. Sense of mathematics. Okay, so that is precisely what you have to understand from this last statement. So we have covered systematic errors or controllable errors. In controllable errors, we have got instrument error. We have got what is the other error? Instrument error, environmental error. What is the other error? Hello?
Randomness.
Hey, I am talking about systematic error. 3 categories. Instrument error,
Environmental,
and observation. Correct? Those 3 errors. Right. And the next category is random errors. So random errors, instrument errors can be minimized by correcting those things. Right? And here random error by taking more number of readings. Gross errors. Okay, now see. Gross errors arise due to human carelessness, okay, and making mistakes in reading the instruments or calculating and recording the measurements and results. For example, you have taken a meter scale as a centimeter scale, or say you have taken millimeter scale, but you yellow gamandaga centimeter scale and tilkondu bardu answer readings tagondbidu. One case. Say you have taken a meter, you have set it to milliampere, but you write the readings in microamperes. Yes, sir, yellow gamanari sir. Nan gortitri sir, confuse madkonde sir. So this attitude, confuse madkonde, that comes under this gross error. Okay, so reading instrument without proper initial setting, taking observations wrongly without taking necessary precautions, exhibiting mistakes in recording observations, putting improper values of observations and calculation. These errors can be minimized by increasing the sincerity and alertness of the observer. Okay? Hello? Right. So I taught you 3 errors. Now, presentation of errors. Okay? Representation of errors. Errors, how do you see? Now, so far we have understood errors. Hello. See, the most important thing in physics is, you have understood. Okay, you have understood. But the next thing is, whatever you have understood, it is in your head. Okay. Now, you have to convey that information to another person. See what is there. See, this person has understood. Okay, this person has understood. Now he has to make this person, okay, to understand. So he has got to convey this to him. Now remember here, in science, representation is very, very important. Okay, so he has been trained to interpret certain ways, and he has also been trained to do that same thing. So that means now if you write like this here and give it to him, and if he is trained to read this, understand what this means, then you have conveyed the truth. Okay, so therefore this representation becomes a very, very important aspect of speaking the truth, right? Because I've seen many people, okay, see, they presume that that fellow knows. Okay, they tell something and they think that that fellow knows. For example, just before the class, I was arguing with one of the students. So he told me, sir, take a scale here and you place the pencil, 20 millimeters. He said, you place the tip of the pencil here. Okay, I did. Then he said, sir, it is 20 millimeters. But I was telling him, see, you should complete it. Where is the base of the pencil? Sir, it is at 0. He is presuming that I already know that it is at 0, that there is no way. Okay, I thought that we are using a pencil, it should be like this. Unless you convey it, we will not get the meaning. Anyways, one essential part of science is training the student to do proper presentation and representation. Okay. So therefore, representation of errors is very important. Now here you see, for the representation itself, formulating the problem in a manner in which it is amenable for representation is also one of the important aspects. For example, okay, so now there will be different types of errors. Okay, there are different types in which you can calculate the error. You can calculate the error, okay, and then you can say, okay, this is how I am going to find the error, and this is the way I am going to convey the error. Understand? See, now there is something fault in this. But now, how are you going to determine the error in that? That is the question. So there can be different methods of determining the same error. But each method can give different answers. Not very wide difference, but there can be substantial difference between the two. And the interesting point is, how much intelligence the person who is conveying the error and how intelligent is the person who is receiving the error. For example, I'll give you an example. So there is one owner, okay, he tells two of his people to count some items. So the first person ought to measure something. So the first person does the measurement of say some object, So he finds that the error in his measurement is 1 centimeter. Okay, the measurement is 1 centimeter. That is, he has measured some rod, okay, and he has got error of 1 centimeter. Okay, many rods he has measured. Now, this is first servant. Another servant, okay, he also does the measurement, but then in his measurement also he does an error of 1 centimeter. Okay, and they are doing different. He is measuring some rods and he is measuring some other type of rods. So say this is X type of rod and this is Y type of rods they are measuring. So both of them say, well, the owner finds out that this fellow is also did the wrong measurement and this fellow also did the wrong measurement. Both of them have done wrong and the wrong measurement is up to 1 centimeter. But then he will fire this person and he will warn this person. Why will he fire this person? This boy is an intelligent boy. This boy who answered here is an intelligent boy. It depends upon the percentage of error. Supposing this person was simply to measure one rod of 1 meter. Okay, and in that he has made an error of 1 centimeter. So the percentage error is 1%. Whereas the second person had to measure a rod as big as 10 meters. And he has made an error of 1 centimeter. So his error will be what? 0.1 centimeter, 0.1%. Correct? And therefore, see, this is a small rod. He could have been careful. Okay? He could have been careful. And this was a big rod. This big rod means this person has to take many measurements because he will be having 1 meter rod. 1, 2, 3, 4, 10 times you have to measure. Probably the error is there. So therefore, you see here, even though the error is same, but you see, he is fired. So therefore, you see, how did you convey this error? See, what did the owner do? Like what this student did. This owner, did not only look at the numbers. He said, well, what is the percentage error? And then he said, this fellow is very careless and he fired. You understood, students? So, see, tomorrow, one fine day, you are also going to become, you are going to start as small employees, and then you can become the employers. So, therefore, it is all about your judgment, how intelligent you are. Intelligence is not that you know, oh, who is the president of that country? Oh, my son is very intelligent. No, you only have information. Intelligence means you must have the right knowledge and sufficient knowledge of a subject or whatever work you are doing, and at the right instance you must be able to apply that knowledge and arrive at a conclusion. Okay, that person is intelligent. So you need to have the right knowledge and you should have the ability to use the knowledge. Such a person is called intelligent person. Okay, unfortunately we use that very wrongly. Okay, see, my father used to tell I am very intelligent. Why? Because I could tell the names of all the ministers in the council. So he said my son is very intelligent. I was not intelligent. I only had information. My memory was good. Anyways, so therefore dear students, you have to now understand how to determine the error and how to report it. Okay, then it makes sense. Right. So here is one instance where there is a concept called absolute error, delta E. There is a concept called absolute error. This is very simple. So you take particular reading n number of times. So you will get different readings 1, 2, 3, 4 n number of reading. Divide it by n. So if you divide it by n, what will you get here? You will get the arithmetic mean. Hello, are you with me?
Yes, sir.
If the true value, see here, now see, this sentence is important. If the true value of the quantity is not given, if it is not given, then the mean value AM can be taken as true value. Correct?
Yes, sir.
Why?
Yes, that is the most precise answer we have got.
Now be careful. Now be careful. You have to be very careful now. You said precise value. Precise. What do you mean by precise value?
More accurate, closer to the.
See, there are. If you have ever read a book or a chapter on measurement, you would not have loosely used this word, because precision is one term, accuracy is another term, resolution is another term, sensitivity is another term. I am sure if you have read any book on measurement, you would have seen all these terms. Am I right? So you cannot say precision, sir, it is more accurate, accuracy, sir, more precision. No, you cannot. They are two different things. I'm sure, right? You're all wonderful students, man. You are going to write the world's toughest exam. Right, anyways. Now, in that, briefly you understand. See, now you have all gone and, in some fair, okay, Jatri. So, when you are all small, even now when I go, you will find balloons and you will get an air gun and then you have to shoot with the balloon, correct? I suppose all of us do that, right? Or there is a bullseye and you have to hit the bullseye. Hello, are you with me?
Yes, sir.
Yes, sir.
Right. Now you see.
Yes, sir.
Yes. Good. So now here you see. This is the screen. Okay. The bullseye is here. Okay. Now I aim my gun to hit this point. So what happens? My first shot will land here. My second shot will land here. My third shot will land here. My fourth shot will land here. My fifth shot will land here. My sixth shot will land here. My seventh shot will land here. Something like this. So here you see I was supposed to land here, but I have landed here. Now you can see here most of my shots have landed here. Okay, around this point. Hello, got it?
Yes, sir.
So here you see the number of, that means I have landed many shots here. That means when I take this point into consideration, if instead of this point, my shots are landing around this point, and it is almost close to this point. So I will say I am more precise. And less accurate. Okay. Now on the other hand, there is another time when I will have one shot here and another shot here and third shot here, fourth shot here, fifth shot here, sixth shot here, and say seventh shot here. Now here what happens, you see, now here if you see, precision is less, but accuracy is better. So I can say I am more accurate and less precise. So you have to see the cluster. So similarly, when you do the measurement, you are supposed to get this measured value, true value, but you are close to something else which is not true. But then you should see the proximity of this, and then you can conclude you are more precise but less accurate. Okay, hello. Now let me more precise and less accurate. But here you are more accurate and less precise. Okay, I'll give you another example. See, now when you go and buy peda in the shop, some sweet in the shop. So you say I want 1 kilo peda. So the meter there will start showing 1.1 kilo. See, it will start showing like this. The readings will be 1.001 kilo, 1.002 kilo, 1.003 kilo, 1.002 kilo, 1.001 kilo, something like this. So you can see here that the readings are around this. Okay. On the other hand, supposing it shows 900 grams or some other values. So I don't have much time to explain. What I'm trying to tell you, there can be situation where the reading, the accurate value should have been 1.000 kg. So I am not close to the accuracy, but I am getting a set of readings which is constant, which is almost very, very close. Then I will say this instrument is very precise, but it is not accurate. It is not accurate, like that. How far it is. I'm sorry, I don't have much time because this is only revision classes for all of you. This theory I have taught for several hours. Okay, and I'm sure everybody would have forgotten. So therefore, what I'm trying to tell you here is, when you take the reading n number of times, and if n is very, very large, then the averaging will come close to one value, and therefore that quantity what you get is definitely very close to the true value. Now this you should do only if the true value is not given. If the true value is given, then you don't have to do this. Did you get it? See, supposing I give you one stone and say it is 1 kilo. That means I have already given you a stone of 1 kilo. The true value I have already given. Then you don't have to do this exercise. Okay, because already you would have got this. Got it? So that means now,
Sir, if you do the trials or large number of times, sir, did you get an answer precise or accurate, sir?
Good question. Good question. Okay, see, now as I told you student, see, now I think you didn't catch what I told here, or I didn't teach properly, either of the ways. See, accuracy means the reading should be very close to the true value. If it is very close to the true value, it is more accurate. If it is less close to the true value, it is less accurate. For example, an instrument will show values like this. 1, 2, 3, 1, 2, 4, 1, 2, 2, 1, 2, 1. Okay, it will go on showing such values. Okay. This is 1. Now, actual reading is 100. Actual reading is 100. But the instrument goes on showing values like this. So, if the instrument goes on showing values like this, then we say it is precise, but not accurate. Correct? Because it is far from this. Understood? On the other hand, if I am getting values like this, 99, 98, 100, 105, okay, then 103, some things like this, then say 97, something like this. Now you see it is all hovering around 100, which is the true value. So this instrument is accurate enough, but if you see the range of variation, okay, it is less precise. It is less precise but more accurate. Correct? Yes, ideally speaking, we want an instrument which is very precise also and very accurate also. Quite possible. So most of the instruments that you see in the places around you, they are both accurate also and precise also. Correct? That's the main difference. Now when it comes to this, when it comes to this value, so you are asking whether this is accurate or this one. See, if you do a measurement, if you know, see here, I knew the true value and I am taking many measurements, then I can comment on the accuracy and precision. Correct? Hello?
Yes, sir.
So this process is only to determine the true value, a number. Okay? If this is not given, then you have to carry out this exercise and get that value. And that value, you have to see, you have done a process. You went on measuring it. You did a process. The outcome of the process is that you get a number. And you interpret this number as a true value. Correct?
Yes, sir.
You have to interpret that value which you obtain by a process and call it as a true value. Okay. Then, now you see, you have taken the first reading A1, A2. So now you go on doing this operation. So every time you do this operation, okay, you are going to get some error, delta A, right? I suppose you understood this. Hello?
Yes, sir.
Yes, sir. Now here a term is important. See here, arithmetic mean of all the absolute errors. Absolute error means you are going to take the modulus of each of the errors, because this error can be plus also, minus also. Okay, and therefore you are going to say now here, you are going to take the mean of the absolute errors. Correct?
Yes.
Now watch out here. See, there are wonderful questions asked. Supposing, see what question is asked in your type of examination. Supposing you take the arithmetic mean of only the errors and not absolute errors, then what will happen? You may end up with 0 only, no?
Yes, sir.
Positive errors can be equal to negative errors. Hello? See, that is not what we want. Understand? Now try to understand. Okay. Now, when you take 1 kilo peda, okay. So I write it as 1 kilo peda plus or minus 1 kg plus or minus 10 grams. So I will write on my board. See, this is how my reading, my machine will give you. That means if he gets 1 kiloton grams or 90 grams, he has to be satisfied. Got it? So what we are interested is from this value, see, from this value 0, 0, okay, I can go to one extreme. What is that extreme value? 110. Another extreme is 990. Correct?
Yes, sir.
I am interested in these two extreme values, and then I will decide whether I should buy from this shop or not. Okay, so I want to determine these extreme values, and these extreme values can be plus and minus, and therefore to get this type of an error report, because you see now, please let me this one. Now at a particular instant of time when you go and buy a peda, at that instant of time, the reading can be this, it can be 110. Or at another instant of time when you go and buy, the reading can be 990. So you see, you are not going to stand in front of the shop and tell him to weigh 100 times. Hey, 100 times, non-science student, physics. Okay, so you weigh number of times, then the error will be less. They will call the mental hospital and ask, then they will tell you they will book you in the mental hospital. Guaranteed. Okay, you can't do that there. So let's be practical. So now at that instant, you are going to get 990 grams. Right. Now since I have already told this is like this, then you have to accept this. You cannot argue. Maybe you will tell, no sir, once more you weigh. Maximum. He will oblige you one more time weigh. And say, sir, 990 ಅದು ಕಡಿಮೆ ಇಲ್ರಿ ಸರ್, ಇದು ನಮ್ಮ machine ಹಿಂಗೈತಿ, ಇದ್ರಾಗ ಹೆಚ್ಚು ಕಡಿಮೆ ನಿಮ್ಗೆ ಬರೋದಿಲ್ಲ. If you want, you take, otherwise go. That's the decent way of telling. So therefore now, if I go by this process of absolute error, then I can get these two numbers. Otherwise, I would not have got these numbers. So therefore, my reporting now is much more better. I am speaking more truth, or a much better truth than if I had only told, come, I will give you 1 kilo peda. I have never spoken the truth. Now by telling like this, I am speaking better. Correct?
Yes.
So that is why you will use the term absolute error. So you will take the absolute values, divide by this. So now the measured value of a quantity A and the error in the measurement delta A can be written as A1 plus or minus A plus or minus delta. This is not A, it is AM. So here, see, this A is what? This A is what? The measured value A. The measured value A and the error in the measurement will be delta A. Okay, and then the true value. So here you see, we are writing the true value as measured value plus or minus delta A. I hope you understood this.
Yes.
Then to true value A. True value means, like, see, okay, done. Anyway, not like that. Okay, friends, I hope I have made myself clear. Now the last sentence is important here. I mean, all sentences are important. So the measured value of a quantity A, wait, measured value of a quantity A and the error in the measurement delta A, which are there, then the true value AT can be written as so and so. Okay? Yes, Arun ask.
Okay, sir. Understood.
Understood now? Good. Arun, I can feel you. Don't worry. It happens. Very good. Last time also you had 3 times you have got similar this one. You paused and then you thought and you only understood the meaning. I am very happy. That is the hallmark of a good student who is understanding. Anyways, I am sorry I am going a bit fast because I have no other choice. But you have every right to tell me, sir, please pause. We just have to think for a while. I will be more happy, and if you say so, I will take a gulp of water. Okay. Shall I proceed on, students?
Yes, sir.
Yes, sir.
Time aatene. Innu 5 ನಿಮಿಷ. Relative or fractional. This is another way of reporting there. Right? So here you will determine the mean value just like how you did earlier. Then you will also get the absolute error. Absolute error of this. So delta A bracket M, or it is also written as delta A bar. So relative or fractional error will mean mean of the absolute error divided by the mean value. When the relative errors are expressed, it is known as percentage error. Right? And just now I gave an example where you will use the percentage error and you will be able to that gives its own intelligence, right? So I just gave you an example of a person, who took 1 centimeter, but then the owner was intelligent enough. He took the relative value or the fractional error, and he was able to do the right judgment. Okay, fine. But remember, don't get confused. It is a mean value and mean absolute error. That's important. Now here often, the students confuse and start writing true value. Okay, so be careful with that, because true value, right, is this. So here you see 80, true value will be equal to A, the value that was measured at that instant of time, plus or minus delta A, right, plus or minus delta A. This delta A is actually the mean of the errors. Delta A, it should be either you write like this. You understood? Hello?
Yes, sir.
Okay, so what it means is, supposing you go ahead by PEDA and it showed some 991 grams, and you will write here plus or minus 10 grams. So the true value of the PEDA, will be how much here? 1001 grams, or it will be how much? 981 grams. Okay, so the customer should go happy that whatever PEDA he has got, see the meter, the weighing machine showed it as 991 grams. Got it? Hello?
Yes, sir.
The weighing machine showed 991 grams.
Yes, sir.
But the customer, having seen this, plus or minus this, 1%. So he will say, okay, that means I have got my PEDA between these two ranges. Either I have got more, or I have got 10 grams more, or I have got 10 grams less. You should be satisfied. And you are telling him the truth. Nodko 10 grams ಜಾಸ್ತಿ ಇರಬಹುದು, 10 grams ಕಡಿಮೆ ಇರಬಹುದು. ನಂಗೆ accurate measure ಮಾಡಕ್ಕೆ ಬರೋದಿಲ್ಲ. ಇಷ್ಟಂತೂ ಬಂದಿಲ್ಲ. ಕರೆದಲ್ಲ? So this is called as true value. So his true value lies between these two values. Okay, friends? Now true value and mean value, I suppose you got the difference. So we are using the mean value to get the absolute errors, right? Then you get you are using the mean value to get the absolute errors and also the mean of the absolute errors. But the true value will be the instantaneous value that you have got plus or minus the mean of the absolute errors. See, I am telling you, these are the common mistake my good friends do after the examination, and then they get less marks, and then they say I did a silly mistake. Okay, to their parents and everybody, and they want to convince everybody, look, I am very good, I am very intelligent, I am very hardworking. Okay, but still you see in exam I did silly mistake. Oh, my son is very brilliant, my daughter is very good, but she did silly mistake. Can't guess. These are all very costly examinations, and these are the examinations, it's very, very important. It's your threshold examination, so you cannot say all that and escape, like how you escaped in your high school days. So I am marking all this very carefully. So please learn these things very, very carefully. Next comes propagation of error. As you see here, so now you are going to do multiple. See, propagation of error means it is not that you do the same. See, I want to measure the length of this pencil. So I will measure it once, I will measure it twice, then I am going to talk about propagation. No. See, now here this propagation of errors means you are doing two distinct measurements. Distinct measurement. That is, I am going to measure the length of this pencil and I am going to measure the length of this pencil. Right? And if I now combine these two pencils, and now what is the length of this pencil? Correct? So
Yes, sir.
what it means is, when you do the measurement of this pencil, there is some error involved. When I do the measurement of this pencil with some other instrument, I might have used it millimeter scale, I might have used centimeter scale, or I might have used millimeter scale only for month. But two distinct pencils, two distinct measurements. So when I do this measurement, that is the number I am going to get, will also have some error in that. and this will also have some error. Now, when I take these, when I want to know the length of these two pencils, then how will the error in the measurement of this and how in the error of the measurement of this will affect the total measurement, the total value of this. I mean, if I keep these pencils like this, how will it affect the total value of this, the length of the pencil? Got it? Now here, I am not going to keep the pencils like this and do the third measurement. I am going to calculate the length of these two pencils. And I am going to write, so this is the length of the two pencils and with plus or minus this error. So there, this term propagation of errors come into picture. Is that clear? Nice.
Yes.
See, for example, now density of a body. So to find the density of a body, well, what is density of a body? First. What is density of a body? First, define.
It is a ratio of the mass of the body to its volume.
Excellent. So the ratio of the mass of a body to its volume. Well said. So it's not mass upon volume. I would have started scolding you. So the ratio of the mass of a body to its volume is called density. So here what do? You take the body. You take the body, right? You measure its mass. You measure its mass. So its mass will be m plus or minus delta. And you measure the volume plus or minus delta. Correct? Hello?
Yes, sir.
Then you are going to divide this. Okay. Then you are going to get the density, and density will be what? Plus or minus delta. Now the thing is, well, so if you know this, then you will be able to determine this. So what is the relation between this, and this? That is what we are going to understand in the next section. Clear, students? Hello?
Yes, sir.
Anyways, it is already 9 o'clock.